So next, let's look at some of the case studies of laser peening. And one of the first applications consisted of laser peening the F101 blade of the B-1 bomber engine. That engine and that blade, the F101, was suffering a great deal of foreign object damage, little nicks. Nicks from ice or from sand, because the engines were pretty low on the wing, and so as it took off, it would suck in debris, cause these nicks, and these nicks would act like crack risers. And so the Air Force had to spend a great deal of maintenance time inspecting the leading or trailing edges of these blades to see if the nick has reached a depth that could cause engine failure. And so they looked to shot peening first to see if that could improve it, but finally they ended up looking at laser peening, and these are the results of a siren test. And a siren test is a test in which the blade is exposed to a series of high-pressure ear pulses for 10 to the 6th cycles. And then the pressure is increased by 10 KSI, and that blade is then exposed for another 10 to the 6th cycles. And that continues until the blade fails. And these are the results of the siren test that sort of really amazed the Air Force and got them quickly on board on laser peening. And so what we have graphed here is the number of the pressure to failure in intervals of 10 to 6 cycles. And this first bar graph is for a blade, an F101 blade, that was shot peened with dual intensity but had no damage. And so it reached 70 KSI after cycling through a number of cycles. Then they put a chisel and an EDM notch in that blade, and they did no treatment. And you can see that for the chisel, it didn't even make 10 to the 6 cycles, and for the EDM notch, it just barely made 10 to the 6 cycles. They were able to improve that effect by applying dual intensity and high intensity shot peening. And they were able to get up to 40 KSI and about 3 times 10 to the 6 cycles. But then when they applied laser peening with the same kind of chisel, 1/4 inch or an 1/8 of an inch EDM notch, not only were they able to achieve greater results than they could with the shot peening, they even got better results in general than a pristine blade that had no damage. And this data was, very important to finding an application for laser peening that could improve fatigue life and could improve the safety of the crew and of the bomber. And as a result, the Air Force applied laser peening, as I mentioned before, to F-14s, F-15s, F-16s, F-22s, and the B-1 bomber.